In this video, we'll continue to talk about some of the problems found in SAT practice test number 8. This is section 4, so this is the calculator section. And we'll kick this one off with number 12. So number 12 gives us this paragraph here that we've got to read through. And they're talking about an insurance agent selling two different types of policies, a $50,000 policy and a $100,000 policy. Last month, his goal was to sell at least 57 policies. He did not meet the goal. The total value of the policies he sold, though, was over $3 million. Which of the following systems of inequalities describes X, the possible number of $50,000 policies, and Y, which is the number of $100,000 policies that he sold? So I think the easiest thing to do here is to recognize that he did not meet his goal of 57 policies. So the total number of X and Y is smaller than 57. Right? He did not meet his goal, so X plus Y has to be less than 57. And just recognizing that can allow us to eliminate choice D. Here's X plus Y is greater than 57. And then also choice B, also X plus Y is greater than 57. So we've got it narrowed down between A and C. It says that the total value of the policies that he sold was over $3 million. So that must mean that $50,000 times however many of that type of policy he sold plus $100,000 times however many of that policy he sold was greater than, looks like I put the wrong number here. My comma's going to be all messed up, but that's supposed to be a 3 million. Sorry about that. 50,000x plus 100,000y has to be above 3 million. Look at option A. Option A says that the total value of the policies he sold is below 3 million. That wasn't the case. Option C shows the greater than symbol right there, so the total value of the policies he sold being above $3 million, and that is what we had happen. 13 gives us this goofy equation, right? A to the negative 1/2 power is equal to X. They tell us that A is positive, and they ask us to find A in terms of X. The place where I would assume that this problem would go wrong, if it goes wrong for you, is with the very first step. If you're going to try to solve this equation for A, you're going to have to recognize how to handle that negative exponent. So anytime you have a negative exponent, you can always move that to the opposite side of the fraction bar and change it to a positive exponent. So right now, this A to the negative 1/2 is placed over a 1 in the original form of the equation. Well, if I want to have a positive power on the A, I'm able to make that happen by moving the A to the bottom of the fraction, changing the sign on the power to a positive, just like you see I've done right here, and then I'm going to have a 1 hold the place of that numerator. If I want to solve this for A, I'm also not going to want A in the denominator. So my next step is to multiply both sides by A to the 1/2, and that leaves me with just a 1 on the left, and then X times A to the 1/2 on the right. I want to isolate A, so now I'm going to divide by X. So 1 over X is equal to A to the 1/2. Now how do I get rid of that 1/2 power? Well, if you raise a power to a power, you multiply the powers, and 1/2 times 2 gives you 1. You might also recognize that a 1/2 power is really a square root, and the way that we undo a square root is by squaring. Either of those options is going to require for you to square both sides of the equation in order to get A to the first on the right-hand side. And when you square this fraction, squaring the top keeps you at 1, squaring the bottom gives you x squared. We are looking at option C. Number 14 here says to find asks us to identify which of the values of x this expression is undefined for. So when you have a fraction is undefined when you have division by 0. So if you set the denominator of this fraction equal to 0, you end up with a quadratic equation. You can solve that by using the quadratic formula. I chose to try to solve this one by factoring, and it did factor, right? So I factored the left-hand side, got x plus 5 times x minus 2. First times first had to give me x squared, last times last had to give me negative 10, and then the outer and inner multiplications had to give me this plus 3x that's in the middle. I set each factor equal to 0. I get one x value that makes this fraction undefined as negative 5. I get a second x value that makes this fraction undefined as positive 2. Negative 5 is not in the list. Positive 2 is. Problem 15 tells us we've got a granite block in the shape of a right rectangular prism. So it's a box, right? A rectangular prism is simply a box. It has dimensions 30 centimeters by 40 centimeters by 50 centimeters. Tells us that the block has a density of 2.8 grams per cubic centimeter. What is the mass of the block measured in grams? So I started by finding the volume of the block. So the volume of the block is just going to be length times width times height, so 30 times 40 times 50. That'll actually give you 60,000 cubic centimeters for the volume. To determine the mass, we're going to have to multiply the volume, which is measured in cubic centimeters, by the density, which is measured in grams per cubic centimeters. They do tell you that density is mass per unit volume. And that's kind of indicated by the units already, so I just kind of went with the dimensional analysis route. If I multiply 60,000 cubic centimeters by 2.8 grams per cubic centimeter, my end result is going to be the total number of grams that the block weighs. And this is actually kind of weird. I was kind of surprised by this when I noticed this. I didn't even toss this into the calculator at all, because if I take 60,000 times 2.8, I'm for sure going to get an answer that's above 60,000. And there was only one option that even was above 60,000. One more try. That's the best I'm going to do, apparently. So problem number 16 here presents us with some information in a table to tell us that we have a study happening, and we've got vitamin C pills being given to certain people, and we've got sugar pills being given to the other people, and we're just going to be asking each group of people whether or not they had any cold symptoms within this 2-week stretch when they were taking that pill. So if you read the question, it asks, what proportion of adults who received a sugar pill reported contracting a cold? So we do not need to look at all of the information within this table. We have to look at the information right here, right? We are only asked about the people who took the sugar pill. What proportion of the adults who received a sugar pill reported contracting a cold? Well, we've got 150 total people who took the sugar pill, and of those 150, 33 reported a cold. So the proportion, people who reported a cold out of the people who took a sugar pill, 33 out of 150. If you reduce that, you end up with 11 out of 50. If you look at this one, we've got a table. So before we even read the question or the problem statement, let's just kind of analyze what we're given. So we've got 20 students enrolled in a college class, and we've got their ages being represented. So looks like we've got a lot of freshmen, a few sophomores, a few juniors, and then a few that I guess we might say are either seniors or maybe non-traditional students. So the table shows the distribution of ages of the 20 students. Yeah, we already know that. Which of the following gives the correct order of mean, median, and mode? All right, so mean is the average. Add them all up, divide by how many you had. So add up all the total ages, divide by 20. Median is the value smack dab in the middle once they're placed in order, and mode is the value that occurs most often. Mode and median are actually very easy to determine based on how this information is presented, especially the mode. The highest frequency, the most students in this class are age 18, so the mode is for sure 18. The median, well, we've got 20 people in the class, so the median is going to be the average of the 10th and 11th values. Well, the 10th and 11th values are both going to be 19-year-olds, right? The 10th value is going to be the second to last 19-year-old, and then the 11th value is going to be the final 19-year-old. So the average of those two 19-year-olds is going to leave us at 19. Now, if you think about the mean is definitely going to be a little bit bigger than the mode or the median, because we're going to be adding on the 4 20-year-olds, the 2 21-year-olds, the 22-year-old, the 23-year-old, the 30-year-old. So the mean is going to be the biggest of the bunch. So we have the mode being the smallest, we have the median being the next smallest, and then the mean is going to be the largest. Last question that we'll talk about within this video gives us a scatter plot here. So if we look at the scatter plot before we even try to really read anything else, we've got leaf litter mass remaining as a percentage plotted on the y-axis, and the mean annual temperature plotted in degrees Celsius on the x-axis. It tells us that this figure shows the relationship between the percent of leaf litter remaining after it's been decomposing for 3 years and the average temperature in 18 forests across Canada. They go on to say that for a particular forest in Canada whose data is not included in the figure, it had a mean annual temperature of -2 degrees Celsius. Based on the line of best fit, which of the following is the closest to the predicted percent of leaf litter remaining in this particular forest after decomposing for 3 years? We don't have to do anything with the 3 years. All this information that's presented is for the amount that's decomposed, the amount that's left after it's been decomposing for 3 years. So that number 3 isn't something we have to multiply by or anything like that. It's just basically how the information was gathered. If you go to where you can find -2 degrees Celsius, that would be a place on the x-axis. And if you go up from that location on the x-axis to the line of best fit, you're somewhere in there, somewhere, I don't know, 70 to 80. We're clearly nowhere near 50. We're clearly above 63. And it seems like we're significantly below 82. So which is the best estimate as predicted from the line of best fit? Well, seems like that's going to be about 70% remaining.